hopefully recording will help that out. Okay, so transforming x to find probabilities of normal distributions. And so we have a normal distribution where we have a number like x, and I want to know all the probability, that's what the statement says. I want the probability of any number that is less than 600, right? Probability, how much probability do I have for a number that's less than 600? So let's say you score 600 on the SATs, which wouldn't make any sense, right? But 600, and it's anybody who scored less would be everybody underneath this curve. Well, that only makes sense because we know that our mean is 500, and we have a standard deviation of 1. So that's where 600 is. And I have that rule, that 68, 95, 97.5 rule, right, under our normal distribution, that bell curve. Since it's one standard deviation, I can tell what the probability would be because I know those numbers under a bell curve. But as soon as you have something like 650, you can't tell that as much, right? You can only estimate. So our z-scores give us an exact probability. That's why we use that z-table. All right, so to transfer it into a standard normal distribution, if you remember from yesterday or from Friday, we take our x, which is 600. We subtract our mean, which is 500, and then we divide by our standard deviation. So 600 minus 500, what? It's 100 over 1, which equals 1. So a z-score for 600 is at 1. Does that make sense? Do you see why it would be 1 no matter what? Think about that for a second. Why do I know for sure that that 600 has a z-score of 1? Anybody know? But what if I didn't know this? What if I just said 600, 600 has a z-score of 1? What if I told you that 700 has a z-score of 2? How do I know that? Why, Edgar? The deviation goes right, it's right smack on the standard deviation. So if this is a standard deviation of 1 and 700 is a standard deviation of 2, I know it has a z-score of 2 because it's perfectly on that standard deviation. Does that make sense? And then so what would be the number that would be a standard deviation which have a z-score of 3? 800 would have a z-score of 3. 810 would have a z-score of 3 point something. Make sense? They match up perfectly. Okay, I just kind of wanted to... Well, we have been. We've been getting numbers. We haven't been getting these perfect numbers. If they were perfect numbers like that, we wouldn't even use a z-score. We would just use this one. I don't understand the question. Okay, I'm going to move on and come back to you because I'm not understanding your question and I don't. Does anybody else understand what she's talking about? Yes. I didn't. Did I have a question? Yeah, no, that's why we're using z-scores, because you don't always have perfect numbers like this. Okay. Go ahead. If it lands on something that's perfectly on the standard deviations, we can use our normal curve that we already know. But if it's a number that doesn't land, exactly, use z-scores to make it comparable. But if it's a perfect number like 600, I don't need a z-score because I already know that number. I know that's perfectly within within the numbers I already know. Okay, I think we're spending way too much time on something where I just was trying to make a comparison. So let's just keep going, and then if we need to, we can come back. Does that make sense? Okay, So again, here's our normal curve. So let me say it one more time. So Christiana, so if I was talking about a number like 80, I would use the normal curve that I have, right? But as soon as I talk about a number like 83, that's when I would transfer it into a z-score. Make sense? Okay, so we saw this on Friday. I think I'm going to shoot to application, and then I'm going to come back to this and see if we can clear this up a little bit more. Okay, does that make sense? So let's go straight to the application problem. Okay. So here's what we're going to do. You're going to write a probability statement. You're going to change it to a z-score. Then you're going to rewrite the probability statement using z, and then you're going to look it up on a table to answer it. That's our process. Okay? Essence, do you want to take a picture of this? Anybody want to take a picture of it? Here's your step. Give you guys a second so you can do that. You're very welcome. Everybody good? Fantastic. Okay. All right, so here's one. A survey indicates that people use their cell phones on average 1.5 years before buying a new one. The standard deviation is 0.25. A cell phone user is selected at random. Find the probability that the user will use their current phone for less than, I'm looking for the probability that a cell phone user will use their phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. Okay, so people use their cell phone on average. So what would how would I make sense of this on average 1.5 years? Not a z-score. It's the mean, right? It's the average. So my mean is going to be 1.5 years. What other piece of information did it give me? My standard deviation. My standard deviation is 0.25. So my standard deviation is 0.25. I'm using these letters because we're talking about what? We talked about this on Friday. Why am I using that instead of x bar? Well, this is the mean and this is the mean. Why do we write them two different ways? This is a standard deviation, but if I was using this mean notation, I would use an S. You guys remember what I told you on Friday? We use this when we're talking population, and we use this when we're talking about a sample size. Okay? So, 1.5 years. So if it's 1.5 is my mean, my next standard deviation would be 1.75. But it wants to know everything less than 1. So that's not a perfect number on my normal curve, right? So I need to transfer it to a z-score. So what's that process again? Right here. I need to change it x to z. Yes, so I'm going to take 1.75, 1 year, and I'm going to subtract it from the z-score. Right, I'm trying to find everything less than 1. So I'm going to take 1, subtract it from the z-score. Now let's think about this a little bit. 1.5, if I were to take one standard deviation going to the left, it would be 1.25, and then one more, it would be 1. So it actually is one of those perfect numbers. Okay, so we're 2 standard deviations over. So when I get this z-score, I should get a 2. Correct? Yeah. You guys make sense of that? Did you follow that? Okay, so 1 minus 1.5 divided by 0.25 equals 1 minus 1.5 is negative 0.5 divided by 0.25. Put it in a calculator. Tell me what you get. -2? Awesome. So did I really need to use a z-score for this? No, I didn't need to. But look it up on your table. Tell me what it is. Look up -2 in your table. Should be a very small amount, right? -2.00. -2.00. It's 0.0228. So 2.28% of people are going to use their current cell phone for less than a year before buying another one. Does that make sense? It does, right? Okay. We didn't rewrite it as, so I'm trying to find the probability of a z-score less than -2 is the way I should have written it if I look back at my steps. I wrote my probability statement with an x. I changed it to a z. I rewrote my probability statement using a z, and then I looked it up on the table. What? You should. Yeah. Okay, thumbs up, thumbs down. How are we doing? Okay. Alrighty. Why don't you guys try this one for me really quick? I'm going to pause it, and I'm going to check your homework in. Okay, so a survey finds that shoppers spend on average, so I hear on average, and I write my mean is 45 minutes with a standard deviation of 12 minutes in the supermarket. So a survey finds that shoppers spend an average of 45 minutes with a standard deviation of 12 minutes in the supermarket. That sounds about right. Yeah? The length of time spent in the store is normally distributed and is represented by the variable x. So the first thing to do is find the probability that a shopper will be in the store less than 24 minutes. So the probability that a shopper X, is going to be in the store less than 24 minutes. So if the mean is 45 minutes here, a shopper in the store at 24 minutes is going to be somewhere over here, correct? And I'm trying to find less than 24 minutes. It's not going to be a very big percentage, right? It's going to be pretty small. The probability will be pretty small. So we're going to turn it into a z-score first. So I'm going to take, here's me changing it into, is that the answer? Did I unveil it? How? I know, but how did I unveil it? Was it already there? Oh. Nobody noticed it? That's okay. It's good to have your answer to see if you're getting it right, right? If you're on track? Okay. So it should be no, it shouldn't be negative. No. The percentages aren't negative, right? Population isn't negative. So you should have put in a negative number. I'll show you right now. Does that make sense? You shouldn't have gotten 99%. Well, we're going to come back to that because I'm going to use that for a second here. Okay. So I take my x, which is 24. I subtract 45 because that's my mean, and I'm going to divide it by 12. Can you tell me what you got? Negative 1.75. Your mean is 45. This says x minus mean. X minus mean. We talked about that just a few minutes ago, right? This is for a sample. This is for a population. It's mu. Yeah, it's a Greek letter. It's a lowercase Greek letter. So it's not just me making a messy M, okay? All right. So 1.75, if I go into my table and look under negative 1.75, negative 1.7, where is it? Negative 1.7, I'm going to go all the way over to 5, and I get 0.0401. 0.0401, which is what I have here. So this is our answer. So the probability of having a z-score less than 1.75 is going to be equal to 4%. 4% of shoppers spend less than 24 minutes in a grocery store. Yes, sir. Thank you. And that goes back to Catherine's question. You got 99 something, right? Yeah. But does that make sense? That's because on the curve, you were all the way over here, and you got it. Now, the reason I said I was going to come back to it, Catherine, is we can use that sometimes if I want to know the area over here. Whoops. If I want to know the area over here, couldn't I just use the negative side? Does that make sense? Yeah. Couldn't I? Does that make? I didn't. Now, see, this is where I didn't want to confuse everybody. But if I want to know the area to the right of a curve, couldn't I? So let's say I want to know the z-score. Let me pull something else up real quick. Let's see. More than 39 minutes. So I'm going to do that with this example. Okay? I'm going to use the opposite. So find the probability that the shopper will be in the store more than 39 minutes. More than 39 minutes, probability, shopper is going to be more than 39 minutes. So my steps, I'm going to change x to z. So 39 is my x. I'm going to subtract my mean and divide it by 12. Somebody give me that number. Negative 0.5. Negative 0.5. So on my, right here, I should be at negative 0.5, and it wants to know greater than. Yes, the area under that part of the curve. You could. You absolutely could. Yes.
Is there a way to find the area without?
Subtracting?
Yeah.
The way to find the area without the z-score? No. Yes. Because that's what we want to know. It wants to know greater than 39 or greater than, I want to know the probability of a z-score greater than negative 0.5. That's what I'm trying to find. So I need to know, here's 0.5, negative 0.5. I want to know the area under that curve that's greater than. No, we changed it to a z-score. We're not using this one. We're using this one. No, you don't get to choose. Okay, somebody, I'm not getting through to essence. Does somebody want to explain it better than me? Because my teacher voice isn't working. But she wants to know, why are we not using the 39? we go. Perfect. Perfectly said, Miss Wiz. She wants to know, but when do I know? The only time we use this one right here, I'm going to pause this because I don't want to have everybody listening. All right, so a score of greater than negative 0.5. I don't have that on my Z chart. If I put in negative 0.5 in my Z table, negative 0.5, what area of the curve is it going to give me? It's going to give me the left. So what's that number? You guys find it for me. .3085. Okay, so that's this side of the curve. If I want this side of the curve, then like Lama was saying, I would have to subtract. So I'm going to take the whole thing would be 100, and I'm going to subtract the left side, which is .3085. You guys do it for me. 3085. What do I get? .6915, which is what we have right here. Make sense? Yes? Okay. I don't think I want to show you the other way on this one. Yes, sir? Can you guys help him with that? Thank you. Questions so far? Matthew? So I looked it up on the table, but this is what you look up on a table. You look up the left side. I want the right side. So I take the whole thing and subtract. This right here. That's your final answer, 69%, which makes sense, right? If we were to look at a normal curve and we were a little bit over here, right, and I add up all these numbers, plus half of this one, 34, plus 13.5, plus 2.35, right? You would get that number too. Yes? You just take out the negative. That's what I didn't want to show everybody. You're understanding it though. Okay? So I'm going to show it really briefly because I don't want to confuse a bunch of people, but yes, you're absolutely right, and I'm going to show you why right now. So if you take off the negative, let's do this in a different, let me take a picture of this. Because I don't want you to think you can just take off the negative and then it but you're right, but I'm going to show you why right now. So you don't think that anytime you can just take off the negative, this is why. If you take off a negative, like Catherine's talking about, if you take off the negative, you're actually talking about this side of the curve. You're talking about right here at 0.5, correct? Which is this left side. Make sense? But isn't this left side the same thing? Let me do this on the other one so we can see it a little bit better. So my left side would be here. If I were to take a picture of that and flip it over, it would be the same thing as this side. Make sense? Okay. So if you want the right side, you can take the opposite and find the area on the left side. They're the same. See how that can be confusing, why I didn't want to tell? You like the old way. Okay, good. All righty. Let's see. Part C. Yes. You're just flipping it. I just don't want you to not understand what you're doing, because then you might get lost. And then you're going to ask yourself, when can I flip it? When can I not flip it? It's better to just know, if you don't understand what we were talking about, just to take the 100% and subtract. Right? Christiana's nodding her head, right? Like, just do it the way I understand it, right? Okay, so find the probability that the shopper will be in the store between 24 and 39 minutes. Okay, so these are the more complicated ones that were on the front side. So let's do this one. All right, so find the probability that you guys want to try it on your own? Well, why don't we do this one together, and then you guys can try the one on your homework? How's that sound? Because there's going to be one on the homework just like this. On the back. Yeah. All right, so find the probability that the shopper, I'm looking for the probability of between 24 and 39 minutes. Well, don't we already have 24 and 39 minutes? Let's look back at this. 39 minutes, the probability of 39 minutes is this number. Right? The probability of greater than, this is greater than 39 minutes. So all we need is the z-scores. So the z-scores for 39 minutes, we transfer that to negative 0.5. Negative 0.5. Does everybody see how I went back and looked and found the z-score? Yeah, we're not there yet. But do you understand where I came up with negative 0.5? Because it's the z-score of 39 that we already found. Okay, I just want to make sure. I'm just going back and getting what I already know. And 24 had a z-score of negative 1.75, right? Negative 1.75. No. Because that's a good question. What? Because we use the percentages when it's absolutely on the standard deviation. If it's exactly 1, we could use that. If it was 25, we just do a decimal. No. 45 minus 12 is 33, right? So if it was 33, that's perfectly on the standard deviation, one standard deviation, and then you can use a standard, you can use the 68, 95, 97.5 rule, the normal curve rule. Okay. What? Yeah. Okay. So I'm trying to find the probability of between negative 0.5 and negative 1.75. Now, essence, I can't use the probability for the last one because this is now saying z is less than 0.5. So that's here and here. I'm trying to find this area. On the last one, I found the area to the right of the curve, right? So I can't use that z-score because it's to the right and I want to the left. Does that make sense? Okay. So what is the area to the left? Control copy. Okay, so I'm going to find the first score. This Z, let's see, what color? Let's use green. So negative 0.5 is right here. What, Catherine, what is it? 23.5? 23.5? No, I just need the z-score for less than negative 0.5. What's that z-score? I can't hear you. Thank you. 30.3085 is this score. That's that percentage, right? The probability. I need to subtract this tail piece right here. Negative 1.75. So I'm going to take the whole thing and I'm going to subtract this part to give me the red. Right? So so this one, what's my z-score for? Less than negative 1.75. 4001. 0401. Okay. So when I subtract those two, I should get the red. So 3, let's just subtract them right here. I should get this number here. Is that what I get? So that's that red area. Questions? All right, why don't you guys try the one on your homework? Let's see if I have that in here. I do not. I'm going to leave this one up for you guys to see it and reference.